Okay, so if you did your homework, this should be pretty easy. Where's the center? 1, -1. Again, make sure you find the x before you figure out where the h is. So we're at 1, -1, so we're right there. Underneath the x is a 9, so how far do we go in the x direction? 3 units over here and 3 units over here. And underneath the y is a 5, so, sorry, underneath the y is a 25. So in the y direction, we're going to go 5 units. So that's going to put us here and down 1, 2, 3, 4, 5. So down here. And then I said you could do something else just to make sure you got it right. 1, 2, 3, 4. Yep. Okay. I said you could draw a little box around here because sometimes it's kind of tough to draw an accurate ellipse. So it's going to look like this. And again, that squared or that rectangle just kind of helps guide the shape there. So there's the center. And then if we were going to label, well, let's see, what else do I need to draw in here to have an accurate graph? Need the foci. Where are the foci? Okay, 4 up and 4 down. Because remember, it's always along the major axis. So we'd go up 4 and we'd go down 4. And how did we get to 4? Okay, big 1 squared minus the little 1 squared. That's going to equal c squared. So c squared equals 16. So c equals 4. And then we could go through and label that, right? Okay, well, the definition of a hyperbola is the set of points on a plane, the difference of whose distance from 2 fixed points is constant. So that's kind of a mouthful. What are those fixed points called? They're called foci. Okay. Now I'm going to pull up something else. Let me just see. Elaine, will you flip the light off there? So this is a little video. I'm not sure if I... There we go. Okay, so let's watch this. Okay, so I'm going to pause that. Oops, right there. Oh, I guess we're not going to be able to pause this. Okay, watch. Okay, there's a focus and there's a focus right here. And this distance right along here and that distance right along there, that yellow line right there, if you can see that. Okay, the difference between the two of those is always exactly the same. So even though this point is going out further, and so we've kind of got this circle around here and then this bigger circle there. Again, that yellow line right there and that blue line right there, the difference between the two lengths is always exactly the same. And you'll notice that the points that this is carving out right here, so this is just kind of approaching a straight line right there. It curved around right here, curved around right here, and then continues going off in each direction. And there are 2 branches. There's another branch over on this side, because if we were to look at this yellow line and that blue line going over to that other focus, the difference between the distances from that point on the hyperbola to these 2 foci, it's always the same. And then what it leaves us with is that little bit right there. I wonder if it lets us, yeah. So irritating. Okay. Anyway, there's the shape there. If you want to look at that again, there are lots of animations on the internet where you can see stuff like that. But that's kind of where the definition comes, or the shape comes from the definition. It's a little bit hard to imagine why that might be useful, but it is very useful. It's used a lot in navigation and in other areas. Just like these other conic sections, they do have their uses, although they seem like they're just, why would anybody want to make something that complicated? So here's the idea. If you did what I said over the weekend and you got done with section 7.3 and you understand how to graph ellipses, hyperbolas are not that much more difficult. There are a couple other things to keep track of. We need to tweak our understanding of an ellipse just a little bit so that we can graph a hyperbola, but they're really not that bad. So if you'll remember from some sections that we already covered, Hyperbolas have equations that have two squared variables, but they have different signs. Okay, so the signs are different. And again, that's assuming that we've written it in general form. Okay, and just like with the other conic sections, if we're going to put it in graph-friendly form, it contains perfect squares. So we are going to have to do some completing the square and stuff like that if it's not in graph-friendly form. If it is, then we're in good shape. And then there's some things that we want to keep track of. Again, so maybe some new vocabulary. Center's not new, but hyperbolas have centers just like the other conic sections have centers. Okay, it's got two branches. It actually comes in two different pieces. We've got foci, we've got vertices, and then definitely some new vocabulary here. It's got what we call a transverse axis, so an axis that cuts across the two branches. Then we've got what's called a conjugate axis. Okay, that's going to be right in the middle of the two of them. And then we've got something called a fundamental rectangle. And then this is always a lot of fun. We've got some asymptotes. Okay, so there are quite a few more things that we need to keep track of on a hyperbola as opposed to an ellipse or a parabola or definitely a circle. But they're actually not too bad. Yeah.
Is there no rectums in this one?
There are no rectums. Thank you for bringing that up. Okay, always a pleasant thought. Okay, so here's the idea. I'm actually going to go through and we're going to graph this one using kind of the idea that we did for an ellipse. So what's the center? Origin. Okay, so centered at 0, 0. I'm going to look underneath this variable right here. It's a y. Underneath it is a 9. How far am I going to go in the y direction? I'm going to go 3. So we're going to go up 3 and we're going to go down 3. Okay. Then I look underneath the x, there's 16, so I'm going to go 4 units in this direction and 4 units in that direction. Okay? I'm going to go ahead and I'm going to draw this rectangle. Okay? Now, you have to draw it when you're doing a hyperbola. You don't have to draw it when you're doing an ellipse. So I've got that drawn in there. The next thing I'm going to do is I'm going to draw in some asymptotes. The asymptotes are the diagonals of the rectangle. Okay, now this rectangle, like I said just a second ago, it's called the fundamental rectangle. So we're going to go right through the diagonal. You'll notice the diagonal goes through the center. So we'll line this up, draw that diagonal. Okay, so I've got the asymptotes taken care of. Okay, and then I just need to know, well, where are these branches? These branches are going to run along these asymptotes, okay, and then curve around. The way we tell whether it opens up or down is which one is positive. So which one's positive here? Y is. So that means it's going to open in the y direction. Okay? Please don't confuse that with a parabola. A parabola is completely different. Okay? It's the negative sign on this in that formula that tells you which way it opens, up, down, left, or right, and it only opens one way. Okay? If you're dealing with a hyperbola, you look at whichever one's positive, and that's the direction that it opens in. So if we're going to draw this, we're going to draw something up here, and we're going to draw something down here. We go right along the asymptote, and then we've got to curve around, and it's got to hit this point right here. And then goes along like that. Does the same thing down here. So right along the asymptote, swing around, curve around so you can hit that point right there, and then it looks like this. Okay? So this is the center. This right here is a vertex. This right here is a vertex. We've got an asymptote here and an asymptote there. Is there any vocabulary that we've left off here? Okay. We need foci. Remember what I said about foci. Foci are always inside the curved part of the conic section. So they're going to be in here, up inside that curved part, and down here, down inside that curved part. We want to figure out how far it is inside. And here's the cool part about this. We take the two of these, and it's just like Pythagorean's theorem. It's right here. A squared plus B squared equals C squared. So I don't have to worry about which one's bigger and which one's smaller. I take the two of those, I add them together, and I get 25. So take the square root of that. So I'm going to go 5 units inside and 5 units outside. So there's a vertex. So 1, 2, 3, 4, 5. There's a focus. 1, 2, 3, 4, 5. There's a focus. Okay? Okay. Got the branches, got the center, foci, vertices, got that one figured out. Transverse axis. Here's the transverse axis. The transverse axis goes right across the two branches. If you traverse something or you do something like transcontinental, you cross it. So we're going to cross the two branches. So here's the transverse axis. And then the conjugate axis runs right down in the middle of them. Okay? So there's the conjugate axis. Now, we don't worry about those too much other than to reference them once in a while, or if they come up in a description of what the hyperbola looks like. So we'd want to know that. And then the only thing that I didn't talk about, well, wait just a second. We haven't done asymptotes, but I did mention this is called the fundamental rectangle, right? We got that. And then this is an asymptote right here. And that's an asymptote right there. Okay? And we could go through and we could label all those points. That wouldn't be difficult to do, right?
No.
Okay. Could we come up with an equation for the asymptote? Sure, it goes through the center, so that's just going to be y equals mx. All we need is just the slope. To go from here along this line, we went over 4, it's the number underneath the x, and went up 3. Has to do with the number underneath the y. Doesn't that make sense? Rise over run. Rise is the y, run is the x. Okay, so this is going to be 3/4 x. What's this one going to be down here? Negative 3/4. So this would be y equals negative 3/4 x. Okay. All right. Any questions? Okay. So a lot of this is just some thinking that's involved here. I'm going to go through and we're going to fill this in. This is by far the most complicated one. There's the most stuff to keep track of. But if you think about it the right way, it's actually pretty easy. So let's run through and do this. If we have an equation like this, it's got two squared variables and they have different signs. So we know it's going to be a hyperbola. If it happens to look like this, where's the center? 0, 0. Okay? We look at the number underneath the x squared term, take the square root, we go that far in the x direction, and we go that far from the center of the hyperbola. We look underneath the y squared term, we take the square root of that, we go that far in the y direction. Okay? And those 4 points, we had this point, this point, this point, and this point. Those points define what we call the fundamental rectangle. Again, it's not part of the hyperbola, but it helps us graph the right shape. Okay? Draw the diagonals of the rectangle using dotted lines and extend them beyond the corners of the rectangle. These are the asymptotes. The hyperbola opens in the direction of the blank variable. Which one? In the direction of the positive variable. Okay? The transverse axis runs in the direction of the positive variable. So it runs in the direction of opening. So because we had a positive squared variable, it's going to open up and down. So the transverse axis runs up and down. Okay? Let's see. The vertices are always on the transverse axis on the fundamental rectangle. So here's one and here's one. They're right where the hyperbola comes up and touches that fundamental rectangle. The foci are C units from the center on the transverse axis. It's got to be on the transverse axis. It wouldn't make any sense to run along the conjugate axis because that's outside the curved part of the conic section. Okay? And then you use the formula. It's just like the Pythagorean theorem. It's a squared plus b squared equals c squared. Now I'm hoping somebody can tell me why it's going to be a plus rather than a minus. We needed to use a minus on an ellipse for a certain reason. We talked about that. Why does it need to be a plus here? Tylin. Like this sign right here?
Yeah, and it opens up and it's not closed.
Good thinking, not quite there. Okay, Trevor.
So it's outside of the...
It's that simple. Okay, think of this little rectangle that we drew for an ellipse. We needed to subtract the small one from the big one so that we could be inside that little rectangle. Now we want to make sure that we're outside that rectangle, so we're going to add the two of those together. If this is A and this is B, if we square those and add them together, we're going to be guaranteed that we're outside that. Does that make sense? Especially since it curves outward. On an ellipse, it curves inside the rectangle. This curves out away from the rectangle. Okay, so that's why. The branches of the hyperbola curve around the foci and approach the asymptotes. So you run along the asymptote, curve around the foci, okay, and then approach the asymptote again. And then we can use this formula right here. Take a good look at this. Y minus k plus or minus m, x minus h. We can use that formula for the asymptotes. Okay? H and k would be the center. The center of the hyperbola is always going to be the center of the rectangle, and the asymptotes are always going to go through whatever the center is. So if you know h and k, you know a point that both of those lines go through. The only thing we need to figure out is, what's the slope? How can I compute the slope? And remember what we said just a second ago. Look at the number underneath the x. Isn't that how far we went in the x direction? Wouldn't that be the run? And look how far we went in the y direction. Wouldn't that be the rise? So the slope is going to be the rise over the run, and the rise is going to be the square root of the number underneath which term? The y. And the run is going to be the square root of the number underneath the x. Okay? Tons of stuff to keep track of. If you know how to graph an ellipse, graphing a hyperbola is not that much more difficult. And I'm actually going to take this entire box right here. Okay? Again, keep in mind all the things that we've talked about. You've got to get it in a graph-friendly form and all that sort of stuff. Make it look like the standard form. And once you get there, we can take that whole box and we can turn it into this little guy right here. So let's fill this out and then we'll graph it. Or you can just remember this. Now, do we need to talk about what the center would be? I mean, you can tell where it's moved just by looking at it, right? Okay. Hyperbolas are graphed just like an ellipse, except the branches open outside. The branches open outside the box. So you're going to start it off the same way as an ellipse. You're just going to make sure that it opens on the outside of the box. Hyperbolas open in the direction of the positive variable. Okay? We use a squared plus b squared equals c squared to figure out where the foci are. Okay? And it's got to be plus so that we're outside that fundamental rectangle. And then we can use the center of the box and the diagonals to find the asymptotes, and we write them like this. And you usually just leave them in point slope form. Don't get hung up on it and say, I only know how to work with slope intercept. That's all I want to work with. Please get used to working with point slope form. Okay? In fact, a lot of people struggle with writing down asymptotes. Okay? I can write down the equation of the asymptotes almost entirely right now. It would be y minus, what's with the y? A minus 1. So we'd write y plus 1. Okay, I'm going to write a plus or minus, and then I write, what would I write? X minus 1. Okay, now, let's figure out what the slope would be. Rise has to do with up and down, right? So we look underneath the y. There's a 9. Take the square root there. That's going to be a 3. Run has to do whether or not we go right or left. What's underneath the x? A 4. Okay? Those are the equations of the asymptote. You don't even have to graph it, and you can tell what they are. Okay, again, grab this same expression right here. Y minus k is going to be y plus 1 in this case. Grab this expression right here. X minus h is going to be x minus 1 in this case. And then all you have to do is put a plus or minus, square root of the number underneath the y on top, square root of the number underneath the x on the bottom. Okay. For some reason, people struggle with that. Hopefully that's pretty easy. Are there any questions? We're going to go ahead and graph this now. We'll confirm we got it right in just a second. Okay, where's the center? Okay, grab the x, 1, negative 1, so we're right here. How far are we going to go in the y direction? 3, 1, 2, 3, 1, 2, 3. How far in the x? 4, 1, 2, 3, 4, 1, 2, 3, 4. And then we draw the fundamental rectangle. What do we draw after the fundamental rectangle? The asymptotes. So we're going to start out here. Line up the corner with the center. Now notice, don't go right for the origin again. Okay, we got to run through the center there. So it looks something like this. And then over on this side, there's the other asymptote. Which way does this open? In the y direction, so up and down. So we're going to run along here, make it hit in the right place, like that, like this. Put arrows on the end. Now, can I go through here and can I label the center as 1, -1? Could I label the vertex right here? That vertex would be 1, 2, and this vertex would be 1, -4. And then I need to know where the foci are. Add the two of these together, take the square root. So we're going to go up 5, that's going to put me right here. Down 5, that's going to put me right there. So let's go ahead and label that. Focus here would be, notice that they all share the same x coordinate. They're on that same transverse axis. So this was up 5 from there, so that's going to put us at 4. This was down 5, so that's going to put us at -6. Am I doing okay there? Okay. Do I need anything else?
I have a question. Would you label the X ones that we did for the fundamental?
Would I label these?
Yeah.
This one right here and that? No. Nope.
Kind of like the ellipse, how we
Yep.
have to label the minor axis.
Okay, now we don't do this very often, so I'm going to change colors. Could you tell me the equation of the conjugate axis?
Y.
Okay, it'd be y equals -1. Okay, can you tell me the equation of the transverse axis? That would be x equals 1. Okay, now let's take a good look at this. I've got the foci, I've got the center, I've got the vertices, I've got the asymptotes drawn in there. I've got a pretty decent picture. If you were going to get 100% on this, you've got to have the asymptotes. We already figured out what they are. Let's just double check and make sure. That point is 1, -1. And how do I get from here to a corner? I'd have to go to the right 4 and up 3. Isn't that a slope of 3/4? And I'd have to go to the right 4 and down 3, so isn't that a slope of -3/4? And if they go through 1, -1, wouldn't we get y minus k plus or minus whatever the slope is, these two guys right here, and the next minus h? So do we have the right asymptote? Okay. Any questions? Okay, go ahead and flip the page over. We'll just do a couple of quick ones. You can get started on the assignment and plow through as much as you can. So let's run through and take a look at this. Where's the center? 0, 0. How far do you go in the x direction? 1, 2, 3, 1, 2, 3. How far do you go in the y direction? 2. Draw that little rectangle. We're going to draw the asymptotes. Which way does this open? Opens in the x direction, right? So to the side. So I'm going to put a little dot right here and a little dot right there. That means I'm going to have to come along here and touch that. So I run along the asymptote, curve around and touch that point, curve back around and run along the asymptote. Same thing over on this side. Doesn't have to look perfect, especially if we label this correctly. So I've got a center of 0, 0. I've got a vertex of 3, 0 and -3, 0. I've got a focus in here somewhere. How do I figure out where the focus is? Yep. Add those two. That's going to be 9 plus 4 equals c squared. So c equals radical 13. A little bit more than 3. I'm going to put the point about right there and about right there. There's the focus. And as long as I label it correctly, again, even if the graph doesn't look quite right, I mean, I should make it look as good as possible, but I went forward radical 13, didn't go up or down. I went back radical 13 and didn't go up or down.
Quick question, Mr. Laws.
Yep.
So this is kind of a problem on the homework, the last homework.
Mm-hmm.
If the vertex, not the vertex, if the center is moved around the graph and there's a radical, do we do like 1 minus radical 13 and 1
Yeah.
plus radical 13?
Excellent, excellent. In fact, I was just going to ask, can you see why they'd call this a conjugate axis? Because if the center was 0, 0, if that's the center and I went forward 13, I'd be at 0 plus radical 13 comma 0, and the other one would be at 0 minus radical 13 comma 0. And same for both of these. I could write that as 0 plus and minus 3. So do you see why they call it a conjugate axis? Okay, equally spaced on either side of that. Any questions? Am I done? Nope, because what have we left off? Okay, so we're going to take the part with the y, so that's going to be a y. We're going to write a plus or minus, the part with the x, a plain old x, and then I just figure out, well, what's my slope? Underneath the x, underneath the y, 2/3. Finished. Any questions? Sure? Okay. All right. I'll come back and I'll do B. If not today, we'll do that tomorrow. Let's take a look at C.
Mr. Lodge,
Yeah.
so do we write that equation for every model?
Yeah, it's going to want the asymptotes for each one. Yep. Okay, so let's take a look at this one right here. Can somebody, without graphing this and without diving into it, tell me which direction this opens? Opens in the x direction, right? Opens to the sides. Okay, the center is at 2, -1. Over 2 and down 1. So I'm right there. Now, could we write the equation of the asymptotes before we even get started? I would hope so. It's going to be, find the stuff with the y. Y plus 1, right? Plus or minus. Let's leave room to put the slope in there. Find the stuff with the x. What do I write? X minus 2. And then if I want to find the rise, what do I look under? Under the y. So that's going to be a 3. And if I want to find the run, I look under the x. That's going to be a radical 7. Okay? In my opinion, I like finding the asymptotes first because my mind's not clouded with an ugly picture or anything like that and thinking about, my gosh, where's the focus and all that sort of stuff. These are the asymptotes. Okay? If you do it that way every time, you're going to get them right. So notice how this is a little bit ugly, because if I'm going to go in the x direction, how far do I have to go? Radical 7. That's a little bit less than 3, so I'm going to go over to here and over to here. And then in the y direction, we're going to go 3 units, up here and down here. So I'm going to make the fundamental rectangle. Now, let me ask you a question that's going to come up sooner or later. Is a square a rectangle? Yes, it is. Is every rectangle a square, though? It's not, okay? Now, before we get too far, let's come back to these asymptotes and let's just double check and convince ourselves that we did get this right. This point is 2, -1. So this would be y minus 1, and this would be x minus 2. So we've got the right stuff with the x and the y. How do I go from here over to here and then up? What's my run and what's my rise? I went over how far? Square root of 7. So that's the run. And what's the rise? How far up did I go? 3. So is everybody convinced we got that right? Okay, let's go ahead and graph the hyperbola. We said it opens left and right. It opens in the positive variables direction, in the x direction. So we run along here. Hit that point right there, and if you need to graph that or label that point or something before you do this, that's fine. So we put that right there, and then we're going to run along here, hit that, and then go out like that. So I've got a center of 2, -1. I've got a vertex of, well, let's see, Zach, can you tell me how I'm going to write this one? Where is that vertex?
2 plus radical 7.
2 plus radical 7, -1. And this one right here?
Is 2 minus radical 7.
2 minus radical 7, -1. Again, see why they call it a conjugate axis? That axis that runs through the center of both of them, doesn't touch them. Okay. So we've got the center, the vertices, we've got the asymptotes labeled. What else do I need? Foci. What's nice about this one? Yeah, you get 16 equals c squared, so c equals 4. So we're going to go 4 units over here and 4 units over here. So that's going to put me at, let's see, that would be 6 comma negative 1 for one focus. And that's going to put me at negative 2 comma negative 1 for the other focus. Okay, are there any questions? Sure. Okay, and I'm going to come down here and we're going to take a look at this type of problem. We'll come back tomorrow and we'll finish this up. If you can get started on the homework, that's great. When we leave tomorrow, you'll have everything you need. We are going to have a quiz on Wednesday, okay? So let's take a look at, well, let's see. Let's look at part B. I think you can handle part B. No, let's do A. We'll do A. Okay, now it doesn't say graph, it just says come up with the equation. So the center's at 0, 0. One focus is at negative 3, 0. There's a focus right there, the center's right there. That tells you a huge amount.
It's going towards the x.
So X is first.
Yeah,
X is positive, right? Okay, there's another focus over here. So we know we're going to have, and what's with the X? Where's the center? It's just going to be an X squared and a Y squared. We put a minus here and we put a 1 there. Take a look at that. You will have test questions like this. You ought to be able to do at least that. Okay? Now, let's see. It's got one vertex at 2, 0.
So there's a 4 under there.
So that goes underneath the X, right? So there's a 4 here. And then how do I figure out this one?
C.
4 plus b
Okay.
squared.
So this tells me C is 3. This tells me, we'll call it A. We'll say A is 2. So A squared plus B squared equals C squared. So that would be 4 plus B squared equals 9. So that means B squared equals 5. Now, do I need to know what B is, that it's the square root of 5? And just for the heck of it, can you write down the equation of the asymptotes, please? Find the expression with the y. It's just a plain old y. Write a plus or minus. Find the expression with the x. It's just a plain old x. I want to find the rise. Which one do I look at?
Y.
The y. What do I write?
5.
Square root of 5. I need to find the run. Underneath that is a 2. So there are the asymptotes. Okay. Now, please do me a favor. Go home, get started on the homework. I think you could probably do most of it. If you get stuck on something, go on. I'm going to finish up the notes, and we may have time to do 1 or 2 questions at the end. You need to have 7.4 done when you walk into class. No questions or anything at the beginning of class on Wednesday, because we're going to take a quiz on all the conic sections we've learned. Okay? Any questions? Yeah. Rationalize it? No, you could just leave it. Good question.